Hi to everyone, myself Dr. Dhananjay Rao, working as assistant professor in the Department of Chemistry. Today I am going to start third module, classification polymer technology. In that I am going to teach classification of polymers. In this session I am going to cover these topics: polymer definition, what is the definition for polymer, and degree of polymerization and applications of different polymers, and polymerization process, and addition polymerization and condensation polymers. I am going to cover these topics. See, first of all, definition of polymer. What is polymer? Polymers can be defined as the large molecules or macromolecules formed by the linkage of small molecule called monomers. What is polymers? Polymers nothing but linkages of monomers. Okay, monomers nothing but small molecules. Okay, these are linkaged together and form macromolecule. That macromolecule called polymer. See, polymer can be defined as the large molecules or macromolecules formed by the linkage of small molecule. Small molecule nothing but monomers. These monomers are linked together and form a large molecule called polymer. In Greek language, poly means many. In Greek language, poly means many. Mer means units. Many units. In Greek language, polymer nothing but many units. Example for polymer, polyethylene. Example for polymer, polyethylene. That is, this is ethylene, CH2 double bond CH2. Okay, this is monomer. These monomers link together and form a large number of molecules like CH2 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 CH2. Like that, it will combine together and form a large molecule. That this molecule is called polymer. This is the example. Ethylene undergo polymerization, it forms polyethylene. Polyethylene. Thus, the repeated unit of monomer is called polymer. The repeated unit of monomer is called polymer. In this example, the monomer is ethylene. In this example, the monomer is ethylene. Ethylene, it is repeated several times and forms a polymer. The repeated monomer is called the repeated unit is called monomer. This monomer repeats several times and these monomers linkage together and form macromolecule, that is called polymer. The number of repeating units in a polymer chain is called degree of polymerization. What is degree of polymerization? The number of repeating units in a polymer, that is called degree of polymerization. The monomer, how many times it repeats, that number is called degree of polymerization. For example, if 100 molecules of ethylene polymerize to give polymer chain, if the monomer is ethylene, if it linkage together form polymer, how many molecules? If 100 monomer molecules means 100 ethylene molecules, okay, link it together form a one polymer, means this ethylene monomer repeated 100 times. Okay, the degree of polymerization nothing but the monomer is repeating how many times, that number is called degree of polymerization. Here in this example, the ethylene molecule is repeated 100 times, so the degree of polymerization is 100. The degree of polymerization is 100. What is the degree of polymerization? The number of repeating units in a polymer chain is called degree of polymerization. Polymers form very important components in our daily life. Polymers form very important components in our daily life. The polymers are highly useful in domestic, industrial as well as medical fields. The polymers have applications in domestic, industrial and medical applications. The following are the reasons for the extensive use of polymers. These are the reasons why we are using extensively of use of polymers. See, most of the polymers are non-toxic and safe to use. Most of the polymers are non-toxic and these are very safety to use. They have low densities, means light in weight. The polymers are having lightweight and the density is very less. So transportation of polymer will be very easy. The transportation of polymers will be very easy. They possess good mechanical strength. The polymers possess good mechanical strength. These are resistant to corrosion and will not absorb moisture. The polymers are not absorb the moisture, so it will not undergo any corrosion when exposed to atmospheric air. This can function as good thermal and electrical insulator. The polymers acts as insulator for thermal and electrical purpose. These functions as good thermal and electrical insulators. The polymers can be used for thermal and electrical insulators. These can be molded and fabricated easily. We can mold these polymers very easily and fabricate very easily. Many of the carbohydrate, proteins and enzymes, DNA are natural polymers. These polymers in our nature, so many polymers are there. Even our human body also consists of a large number of natural polymers. Example, carbohydrates, proteins, enzymes, DNAs and RNAs. These all are made up of natural polymers. Classification of polymers based on origin. Based on origin, the polymers are classified into two types. First one is natural polymer, second one is synthetic polymer. Based on origin of polymers, the polymers are classified into two types. One is natural polymer, second one is synthetic polymer. Natural polymers. In that, I am going to discuss about natural polymer. See, in natural polymer, those polymers which occurs in nature are called natural polymers. The polymers which are occurred in nature are called natural polymers. Example, starch, cellulose, proteins, natural rubber. These are comes under natural polymers. These are occur in nature. Okay, these polymers occur in nature. Synthetic polymers. What are those synthetic polymers? The polymers which are prepared in the laboratory are known as synthetic polymers. The polymers which are prepared in laboratory, those polymers are called synthetic polymers. Example, PVC. PVC nothing but polyvinyl chloride and polyethylene, synthetic rubber, nylon 6,6. These are the example for synthetic polymers. These can be prepared in laboratory only. Next one is polymerization. What is meant by polymerization? It is a fundamental process. Polymerization is a fundamental process. The low molecular weight of compound converted into high molecular weight of compound through linkages. That process is called polymerization. What is polymerization? The process of conversion of low molecular weight compound into high molecular weight compound through linkages. That process is called polymerization. The polymerization is a process of conversion of low molecular weight into high molecular weight through the linkages. That process is called polymerization. The types of polymerization. See, there are two types of polymerizations. They are addition polymerization. In that, two types are there. One is homopolymerization and copolymerization. And second polymerization is condensation polymerization. There are two types of polymerizations are there. They are addition polymerization. In that again two types are there. One is homopolymerization and second one is copolymerization. And second polymerization is condensation polymerization. See, now I am going to discuss about addition polymerization. See, we can also call as addition polymerization chain polymerization. See, addition polymers are formed by adding monomer units without any loss of atoms or groups. What is addition polymerization? Addition polymers are formed by the adding monomers units without any loss of atoms or groups. Two monomers combined together. One monomer is repeating several times, but on linkages there is no loss of atoms or groups. That process is called addition polymerization or chain polymerization. These polymers formed by the polymerization of monomers containing double or triple bond. For the formation of addition polymerization, the monomer should contain unsaturated bonds like double bond or triple bond. The monomers should contain double bond and triple bond. Then only they will undergo addition polymerization. Example, ethene or ethylene. Ethylene CH2 double bond CH2. Okay, this is ethylene. Here this is monomer. This monomer contain one double bond. So it will undergo polymerization. It will form addition polymers. See, CH2, C double bond, CH2. Okay. Again, if you take one more monomer, okay, these two are linked together, forms CH2 single bond, CH2 single bond, CH2 single bond, CH2 single bond. Like that, this ethylene monomer repeat several times. It will undergo addition polymerization. In this process, there is no loss of or gain of atoms or groups. There is no loss of atoms or groups. Only here the single double bond and triple bonds are converted into double band and single bonds. So there is a change in these unsaturated bonds. There is no loss of atoms or groups present in the monomer. Okay. And next example is vinyl chloride. The structure of vinyl chloride is CH2 double bond CHCl. This is monomer. For addition polymerization, the monomer should contain at least one double or triple bond or unsaturated bond. So in this polyvinyl chloride, there is a one double bond. Okay, there is a one double bond. It will undergo polymerization. It will undergo polymerization. It will form CH2 CHCl. The vinyl chloride monomer is repeated several times. The vinyl chloride monomer is repeated several times in this polyvinyl chloride polymer. This vinyl chloride undergo polymerization forms polyvinyl chloride. Here there is no loss of atoms or groups. So it is example for addition polymerization. What are the example for addition polymerization? There are two examples here I have mentioned. One is polyethylene. Polyethylene can be prepared by using ethylene monomer. The ethylene monomer should contain at least one double or triple bond. Okay. Here second example is vinyl chloride. Here also there is one double bond. It will undergo polymerization and it forms polyvinyl chloride. In this addition polymerization, there is no loss of atoms or groups. And I have discussed the addition polymerization. There are two types of examples are there. One is homopolymer and second one is copolymer. See what is homopolymer? Polymers made up of only one type of monomers. The polymer is made up of only one type of polymer. That polymerization is called homopolymerization. The process is called homopolymerization. See polyethylene. If you take polyethylene CH2 double bond CH2 undergo polymerization forms polyethylene CH2 and this monomer unit repeat several times. Only here monomer is one, that is ethylene. The same one monomer is repeat several times. That polymerization is called homopolymerization. Example polyethylene and polyvinyl chloride. In this polyethylene only one monomer, that is ethylene undergo polymerization forms polyethylene. Here only one monomer, that is ethylene monomer repeats several times. And in example polyvinyl chloride, the monomer is vinyl chloride, that is repeats several times. Here only one monomer repeat several times. That process is called homopolymerization. See copolymerization. What is copolymerization? Polymer formed by the reaction between different monomers. The polymer forms between two monomers. That polymerization is called copolymerization. Example buna S rubber. Here butadiene is one polymer. Here buna S rubber. In this buna S rubber polymer, butadiene is one monomer and second one is styrene. The second one is styrene. Second monomer. This is one monomer. This is another monomer. These two monomers linked together form a buna S rubber. This is the example for copolymerization. See here only one monomer repeat several times in homopolymerization. In copolymerization what happens? If the polymer forms between two or more than two types of polymers. See M1 is one type of monomer, M2 is another type of monomer. These two monomers linked together form a copolymer. Okay, that is buna S rubber is example for copolymer. In that buna S rubber, two monomers are there. One is butadiene and second one is styrene. See copolymerization. The polymers which are obtained by the polymerization of two or more monomers are called copolymer. What is copolymer? The polymers which are obtained by the polymerization of two or more monomers are called copolymerization. This process is called copolymerization. See example butadiene. Butadiene structure is CH2 double bond CH double bond CH2. Butadiene 1 2 3 4 4 carbons are there and these two are double bonds. Okay, 1 2 butadiene 1 comma 2 3 4 1 4 butadienes. Okay, it is butadiene structure, this one, and it reacts with styrene. Okay, these two polymers, one is butadiene, other one is styrene. Styrene CH double bond CH2. This is one type of monomer. One type of monomer is butadiene. Another type of monomer is styrene. These two undergo polymerization. These two molecules undergo polymerization, form bunious rubber. Forms bunious rubber. This is the example for copolymerization. This is the example for copolymerization. In this copolymerization, two are more than two monomers linked together and form a polymer. That polymer is called copolymer. Then second one is condensation polymerization. See, what is the condensation polymerization? Polymers formed from the functional group of monomers with the elimination of a byproduct. In the condensation polymers, there is a elimination of byproducts. In addition polymerization, there is no loss of atoms or groups. But in case of condensation polymers, there is a elimination of byproduct. Okay, and with the formation of new functional groups are known as condensation polymers. Okay, in the condensation polymers, the monomers contain one type of functional groups, and on formation of polymer, the functional groups are changes. See, example nylon 6,6. In these two monomers are there. One is adipic acid and other one is hexamethylene diamine. One monomer is adipic acid and other monomer is hexamethylene diamine. These two type of monomers link together and are undergo polymerization from nylon 6,6. See, in the adipic acid, what are the functional groups are there? The functional groups are C double bond OH and C double bond OH. Means in adipic acid there is a functional group carboxylic acid. Similarly, in case of hexamethylene diamine, there is a functional group amine NH2 NH2. Here in first monomer adipic acid, there is a one functional group, that is carboxylic acid functional groups are there. In the hexamethylene diamine, there is a one functional group, that is amine functional groups. Okay, these two undergo polymerization. These undergo polymerization from nylon 6,6. In this, there is a formation of new functional group, that is C double bond OH react with NH2. There is elimination of water and form C double bond OH. Okay, and NH2. Okay, R. There is a loss of water, N minus H2O forms R C double bond O NH. There is a new functional group is developed here, that is amide functional group. Okay, there is a after switch C definition. Polymers formed from the functional group of monomers with the elimination of byproduct. Here there is a elimination of byproduct water with the formation of new functional group. See, in starting monomers there is a carboxylic functional group and amine functional groups. But in the product polymer, what is the functional group? New functional group is formed, that is amide. This is the example for condensation polymerization. In the condensation polymerization, there is a loss of byproducts. Okay, there is a loss of byproducts or loss of atoms or groups. In addition polymer, there is no loss of atoms or groups. But in condensation polymer, in addition polymers, the monomer should contain at least one double or triple bond. In condensation polymers, the monomer should contain at least one type of functional group. Okay, one type of functional group, and these functional group undergo polymerization or undergo reaction and form in product new functional group, that is different from the monomers. Okay, this is the condensation polymerization. Example 2 is pterylene. This is the example 2 for condensation polymerization. See, in this the monomer is ethylene glycol. In this the monomer is ethylene glycol. See, the ethylene glycol structure is CH2, CH2, OH and OH. This is structure for ethylene glycol. This is reacts with terephthalic acid. This is terephthalic acid. See, structure of terephthalic acid, C double bond O, OH and C double bond O, OH. In this monomer contain functional group hydroxy. The ethylene glycol contain the functional groups OH, hydroxy functional groups, and terephthalic acid contain two functional groups, that are carboxylic acids. The ethylene glycol monomer contain hydroxy functional groups and terephthalic acid contain carboxylic acid functional group. These two monomers undergo polymerization. These two molecules undergo polymerization, forms dacron or pterylene. Okay, in this, what is the new functional group form? See, OH. This monomer contain hydroxy functional groups. This monomer contain carboxylic acid functional groups. These two monomers undergo polymerization, means condensation polymerization form, product form, and this, see here there is a new functional group, that is ester. The new functional group is formed in the condensation polymer is ester functional group is formed. In starting monomers, there is a hydroxy functional group and carboxylic acid functional group. But resultant product polymer, that is condensation polymer, that tyrylene, in that a new functional group is formed other than carboxylic acid and hydroxy functional group. That forms ester functional group is formed. See, differences between addition and condensation polymers. See, addition are chain polymerization, condensation are step polymerization. See, these are the differences. First difference is the monomer must have at least one multiple bond, that is double or triple bond. In the addition polymerization, the monomer should contain at least one double or triple bond. See, in the condensation polymers, the monomers must have at least two identical or different functional groups. In the condensation polymers, the monomer should contain at least one type of or two, at least it contain two identical, means two identical functional groups, OH-OH or COH-COH, or different functional group, means one is one functional group, other one is other functional group, means the OH one functional group, it should contain hydroxy functional group or other one carboxylic acid functional group, like that. Okay, see, the monomer must have at least two identical or different functional groups. Example, glycol. In example, glycol and nylon 6,6. In this, the monomers contain, glycol contain two OH groups. Okay, identical functional groups. In nylon 6,6, two monomers. For preparation nylon 6, two monomers are there. One is, see, in the previous example, one is ethylene glycol. See, here two OH functional groups are there. Same identical functional groups are there, monomer. In this monomer, two identical functional groups are there. Those are carboxylic acid and carboxylic acid. Okay. In addition polymerization, the monomer should contain at least one double or triple bond. In the condensation polymers, the monomer should contain at least two identical or two different functional groups. The second point is monomer add-on to give polymer and no other byproducts formed. In addition polymerization, the monomers are linked together and forms a chain polymer, and there is no byproduct formation takes place in the addition polymerization. In this, the monomer condensed to give a polymer, byproducts such as water, methanol, etc. will be formed. In condensation polymers, there is elimination of byproducts. The third point is the addition of monomers results in the formation of the polymer. The monomers addition together and form a polymer, that is in addition polymer. In this, the condensation reaction between monomers of result formation of the polymer. The condensation reaction takes place between the two monomers in the condensation polymers. Here there is elimination of byproducts. In the addition polymerization, there is no elimination of byproducts. The fourth point is the molecular weight of the resultant polymer is multiple of the monomer's molecular weight. See, the molecular weight of the resultant polymer is a multiple of the monomer's molecular weight. See, here there is no loss of atoms or groups present in the addition or chain polymerization. So, if you take CH2 double bond CH2, okay, these ethylene undergo polymerization forms CH2, CH2, CH2 like that. Okay, here there is no loss of atoms or groups takes place. So, here how we can calculate the weight of how we can the molecular weight of the resultant polymer. The molecular weight of this resultant polymer is the multiple of the monomers molecular weight. So, how many number of these monomers repeated in the polymer, we can simple multiplication of these numbers with this molecular weight of monomer, we will get the molecular weight of the resultant polymer. So, because there is no loss of or elimination of atoms or groups. So, in this way we will get the total molecular weight by multiplying. See, if ethylene molecule is repeat two times, means if you multiply with 2 with the molecular weight of this monomer, we will get the molecular weight of the resultant polymers. But in case of condensation polymers, what happens? See, the molecular weight of the resultant polymer is not multiple of the monomers molecular weight, because in condensation polymers, between two monomers, the two monomers condense together and there is a loss of atoms or groups. So, in this way we can't calculate the molecular weight of the resultant polymer by the simple multiplication of the monomer molecular weight. Okay. The fifth point is Lewis acids or bases or radical initiators or catalysts or in addition polymerization we can use this type of catalyst. In case of condensation polymers, we can use catalyst in the process of different molecules. We can use different molecules for the catalyst in the case of condensation or step polymerization. The sixth point is common example for addition are see polyvinyl chloride and polyethylene Teflon. These are comes under simple addition polymerization. These are the example for addition polymerization. What are those? Polyvinyl chloride and polyethylene and Teflon. These are the example for addition or chain polymerization. What are the example for condensation or step polymerization? See, nylon 66, bakelite and silicon. These are the example for the condensation or step polymerization. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.